Removable partial denture preparation and design review. When you study about the partial denture metal framework and preparation for the abutment, the cast should be mounted. And what is the reason for cast mounted? The reason is this: in metal partial denture framework, it does cover some of the teeth on the occlusal surface or cingulum area. So for example, in this case, number 6 does have, K9 has a cingulum rest as an indirect retainer. And when you cover the metal on the area, either the lingual surface or the occlusal surface, you need to be carefully observe where is the opposing contact. So when you look at the cross-sectional view, this is an example of occlusal rest used on the premolar. And when you look at the sectional diagram, you notice that there are very little space for the rest seat, which is supposed to be on the metal occlusal rest. But you need to be careful because it depends on the words opposing teeth. You cannot fabricate the occlusal rest anything higher than opposing contact. And that's the reason why you need to check the mounted cast. Make sure looking at the opposing contact for the design. Let's look at the abutment preparation. So based on your metal framework design that you cover, for example, this particular condition, we have several occlusal rest seat. And we'll take a look at how this preparation will take in place. The framework design, which we covered the last session, you need to identify the candidate classification, and starting with the guiding plane, and which will provide the stability of the framework structure and the path of insertion, and then major connector design. So you need to choose for the maxillary 4 different designs, or mandible 4 different major connector, and you got to choose one of those design. And then you are designing the direct retainer. And then after that, identify the fulcrum line and looking for the indirect retainer position. And last one is minor connectors. That's including the saddle and connecting all the components together. So that's the sequence that how you design the metal framework. The first preparation that you're going to start is the guide plane. As we discussed, the guiding plane is the one that you try to make a parallel surface on the proximal surface of a abutment teeth. When you prepare the proximal surface, as you know, the distal or major surface of the tooth are not flat, it's mostly convex shape. And we are trying to modify only the coronal half of the proximal surface. Again, we are keeping the cervical undercut as it is. Otherwise, if you're preparing entire proximal surface, your modification or reduction amount of the tooth are too significant. So the guiding plane preparation only been taking place on coronal half of the proximal surface. And this is another view. And what you want to do is you try to achieve about 3 millimeter height that it is parallel to the path of insertion or your survey line. When you look at the guiding plane preparation from the occlusal view, you also need to be careful to respect the outline contour of individual tooth. So 3 millimeter vertical height preparation are all same, but as you notice, when you prepare the guiding plane on this distal surface of the premolar, you need to respect convexity of the contour, and you're following the outer contour. So you're making rounded, flat surface. Do not make it straight cutting, because this one also damage the abutment tooth, because in the center portion, the preparation amount of the dentin are too significant. So when you prepare the guiding plane, you need to respect the outer contour, and you only going to prepare coronal half of the surface. When it comes to the molar, quite often the molar teeth are drifted, and in that case, and common to the mesially drifted, then as you notice, the preparation is only taking place on the coronal half. So we are leaving the cervical undercut as it is. This is the only place as guide plane preparation. The second preparation is the receipt. And receipt does have a very unique measurement which you must follow the dimension. The dimension is in the depth of the receipt is 2.5 millimeter, and the width of the receipt are also 2.5 millimeter, which means when you check, the ideal tool for checking your preparation is 2 millimeter amalgam condenser. That's the amalgam condenser, one of the largest size in the kit. That amalgam condenser should freely fit right onto the receipt to confirm the diameter of the receipt preparation. During the preparation, if the receipt are positioned in between the adjacent teeth, meaning the adjacent teeth is still there. So for example, this is the major receipt preparation. You make sure you do not breaking the contact points. Therefore, when you prep although it's a major receipt, the receipt position is slightly toward to the lingual side, so that you do not need to break the contact point between the adjacent teeth. So it's slightly positioned lingually. Again, the diameter, 2.5 millimeter depth and the width are respected. So therefore, the minor connector from the lingual side connecting to the receipt are easily accessible. This is actual typodont teeth. This is the diagram. How does it look like from the view from the proximal and occlusal? And this is actual major rest preparation on the typodont premolar teeth. One on number 20, major receipt. Again, make sure you look at the size and the dimension. Again, to check with the amalgam condenser will be very useful tool when you check the size of your receipt. And please take a note, the contact area was not prepped at all during this major rest preparation. Not only the depth and the width preparation diameter, you must also respect how deep the receipt vertically. And the vertical depth will be 1.5 millimeter depth, as you notice. And also, instead of flat purple floor or floor surface, it will be spoon shape of purple floor. The reason you prepare the receipt with a spoon shape, meaning the marginal ridge area will be slightly higher than the center of the receipt, to preventing the slippage of your receipt preparation. So for example, if you do not have a spoon shape, then on the vertical bite force applied onto the receipt, this metal structure receipt tend to slip away from the tooth if you do not have spoon shape. Therefore, all the receipt preparation, the center of the receipt will be slightly about 0.5 millimeter deeper than the marginal ridges. This is the incorrectly prepared rest seat. The purple floor does not have any spoon shape, and therefore the rest seat under the bite force should stay on top of the occlusal surface. Instead, this one slip away and sliding backward. So this is the failure of incorrectly prepared rest seat. Another clasp design called Embrasure Clasp, and this one, due to the design which is crossing the occlusal surface from lingual to the buccal, you need to prepare the slot preparation. These are Embrasure clasp are designed on two teeth adjacent together. Therefore, you need to provide occlusal space so that metal structure could pass from the lingual to the buccal. We call the slot preparation. The slot preparation dimensions are this: minimum 2 mm space from lingual to the buccal. So through and through, you need to look for the 2 mm width of slot preparation. It's straight buccal lingual 2 mm, larger than 2 mm, but not more than 2.5 mm. So meaning the condenser, large amalgam condenser, are tightly fitting onto this slot preparation. And then you will having half circle rest seat preparation in addition to the slot preparation. Each side is 1.5 mm more toward to the center of the tooth. So total width of embrasure space preparation will become 5 mm. From here to here will be 5 mm. The slot will be 2 mm slightly larger, so probably 2.1 or 2.2. So let's take a look at the Embrasure clasp preparation. This is a slot preparation, and that's the half circle. And this is a type button teeth preparation. Again, the total width from here to the preparation center of the rest seat will be 5 mm. And this slot preparation from here to here, which is from lingual to the buccal, through and through, will be 2 mm. Again, make sure you check with the 2 mm amalgam condenser. The amalgam condenser should fit tightly to passing through this slot preparation. Of course, the half circle of the rest seat also accommodate half of your 2 mm amalgam condenser. This is the view on actual Embrasure clasp preparation done on the existing crown. And this is how it will look like, the Embrasure clasp. As you notice, the clasp assembly travels from the palatal to the buccal, and that's the slot preparation and the rest seat. When this example of case, the number 2 and 3 existing crown with the design of Embrasure clasp in place built into the crown design. And number 6 and number 11, the rest seat are already prepared. Then your metal framework design could be like this: guiding plane. So the guiding plane will be on the major of the number 3, distal of number 6, distal of number 12. And then the major connector, we use the U-shaped major connector. Direct retainer, we use Embrasure clasp and another eye bar. And number 12, because of the distal extension, we chose one of the stress releasing clasp we call RPI design. We're going to look at this RPI design a little bit more detail later on. Of course, the indirect retainer is placed on tooth number 6, which already have a rest seat preparation. So this clasp assembly will work as a direct retainer and indirect retainer function. So the one component could play two roles, direct retainer function and indirect retainer function. When it comes to the single rest, which is applied to the anterior teeth, these are the dimensions to prepare. Due to the contour of the lingual or cingulum area, the preparation will be placed in this direction. So number one, we're gonna make a slot preparation, flat surface, and this flat surface will only have a 1.5 millimeter flat bottom, and from major to distal lengths will be about 2.5 to 3 millimeter with the flat cingulum stop. When you look at this preparation, you could notice number 6, number 11 does have cingulum rest. When the occlusal contact are located, you must provide room below the occlusal contact. Otherwise, your metal framework will be in the contact area, which need removal of those metal structure due to the opposing contact. So be careful when you prepare the cingulum rest. You always check opposing contact. About the clasp, we shortly discussed there are two different categories. One is the supraverge clasp, which is showing on this left side picture. And the other category is infraverge clasp on the right hand side. Typical type of supraverge clasp is called Acres clasp or circumferential clasp. This is the image of the Acres clasp, and there are three components. One is retentive arm, and the other side is called reciprocating arm. And then the rest seat. And all these three components attach from the one direction. So in this particular case, the major side, starting retentive arm, reciprocating arm, and rest seat. From these three components are making Acres Clasp Assembly. When it comes to the retentive arm on this side, the only tip of the retentive arm will be engaged below the survey line. Remember, during the survey session, you need to identify where is the height of the contour, which is called the survey line, because you need to provide the retention for the metal framework structure. These retentive arms should engage undercut area. So this diagram showing the red survey line, only the tip portion, not entire arm, only the tip will engage below the survey line. When the survey line are only present on the medial surface instead of distal, then conventional Acres clasp, which is coming from the medial surface to the distal, doesn't work because the location of the undercut are present on the medial buccal side. So this is another type. If that's the condition of the tooth, it's called the ring clasp. Will have a medial rest, reciprocating, and the bracing arm on the lingual surface, but continuously travel to the distal surface and engaging making the retentive arm on the buccal side. And the tip of these ring clasps are engaging onto the undercut area. So this different structure we call the ring clasp when it have a different undercut location compared to Akers clasp. Still, this is a supraverge clasp. Another type of supraverge clasp are called Embrasure clasp. These are basically two Akers clasp back to back located. We're gonna show the infraverge clasp category. Infraverge clasp are the clasp assembly come from the gingival portion and goes up and engage onto the undercut area. We are only talking about the retentive arm condition. So retentive arm are deciding whether supraverge or infraverge clasp. There are I bar. This is the I bar, one of the infraverge clasp. Watch the tip of the I bar are engaging on the undercut area. This is Y bar clasp. This is a T bar and half T bar infraverge clasp. Other than I bar, Y and T bar are used when the undercut amount are very minimum and you want to utilize medial side and distal, both sides of undercut. So when you look at the Y bar compared to I, it engaging two retentive tip on both medial surface and distal surface. So it provides greater retention when abutment tooth has very minimum undercut. When you have enough undercut, which is 10 gauge, you do not need to choose Y bar because I bar one tip will have enough retention. This is actual case picture showing I bar clasp assembly and Y bar and half T bar. We talked about the stress-releasing clasp in the previous session. Let's review one more time. There's a three clasp assembly are fall into stress-releasing: RPI, RPA, and combination clasp. The reason is the mechanism for the stress-releasing RPA, which is medial rest seat and I bar. Under the bite force, the entire prosthesis, especially the retentive arm, move around the axis of the rest seat, which is medial rest seat, and the I bar rotate downward and medially, therefore disengaging from the tooth undercut. Therefore, under the movement, the I bar tip will not torque abutment. Instead, it disengages from the undercut. That's why we call the stress-releasing clasp due to the disengagement property. This is the diagram of Rpi Clasp Assembly. Make sure you remember this. The RPI stands for the medial rest, proximal plate, and I bar. All these three components called Rpi Clasp Assembly. One of the three type stress-releasing clasps. This is RPA design drawing. Medial rest, proximal surface, proximal plate, and Akers clasp retentive arm used. So this assembly is called Rpa Clasp Assembly. Again, this is second type of stress releasing. The third clasp assembly of stress releasing clasp are combination clasp. Combination clasp use casting or printed metal framework along with wrought wire soldered into the metal framework structure. Due to the property of the wrought wire, it used to be formerly PGP wire used, is platinum gold plated wire. Its wire retentive arms are much more flexible. So because of flexibility, this combination clasp will not torque the abutment during the movement of entire metal framework. So that's why we call the stress releasing clasp. So let's take a look at the example of this case. Lingual floor depths, which is measuring from here, are 8.9 millimeter. So it's enough room for the lingual side. Number 31 has no buckle undercut, meaning when you survey this cast, the buckle surface of this tooth number 31 does not have any undercut. Then what we should do? In that case, this number 31 used Acres clasp, but take a look at carefully. Acres clasp will have a retentive arm, reciprocating arm, and the receipt. Normally, the retentive arm goes to the buckle surface, but this case, we already find out the buckle surface does not have any undercut. Therefore, we flip the retentive arm and the reciprocating arm. So the buckle surface will have a reciprocating arm, and the lingual side, this is retentive arm. Therefore, the lingual side of the tip are located below the undercut area. You need to identify this in the prescription when we request making the metal framework. So this one, due to the no buckle undercut, although it is typical Acres clasp, retentive arm will be positioned on the lingual side instead of buckle. Other designs are pretty straightforward. Guiding plane, major connector used for the lingual plate because of anterior teeth are missing. And on the distal extension side, we chose the stress releasing clasp called Rpi Clasp design. When there's a tooth are guarded, so for example, this particular condition, mandibular, tooth number 29 is endodontically treated and crowned, and also it does have a mobility 1+. And we identified tooth number 29 are guarded prognosis. What design modification we should place to accommodate tooth number 29 instead of extracting? You could design in a way that you could skip tooth number 29, guarded tooth, and making the abutment tooth in front of it. So in this case, 28, which is natural tooth, are the abutment tooth. So we are using abutment instead of 29, use 28. Rest seat is placed on 28, and eye bar are extended from the back all the way to the 28. So that's how you skip any guarded prognosis tooth if you do not want to use that tooth, particular tooth. Another preparation is called the dimple preparation. In a case that you design and you wanted to have engaging a clasp, but you don't find any undercut area on that particular tooth. In that case, you could create undercut by simply placing the dimple preparation on the buccal surface area that you want to engage the retentive arm tip. And this, for example, this particular premolar is showing the dimple preparation on the premolar will be located cervical 1/3 and middle 1/3 junction line, and that's called the dimple preparation. So in the rear case, we identify this maxilla, there's no undercut on tooth number 6, which you wanted to use as an abutment. In this case, if there's no undercut, you could place dimple placement as here, and when it's placed dimple, make sure your retentive arm tip are engaging those dimple preparation, and that's how you gain retention for your metal framework. Another sample, that number 5 has endodontically treated and the crown and guarded prognosis, meaning you do not want to use as number 5 abutment. So we're going to skip number 5 and we're going to use number 6 as our PD abutment. Therefore, design could be engaging number K96, not number 5, and number 5 are completely skipped during the metal framework design. So it does not have any receipt nor the retentive arm on number 5. So designing particular condition, identify the guiding plane. So distal of tooth number 5, number 4 distal, 6 mesial and 10 mesial and 12 distal, and major connector I would use the U shape because anterior teeth are missing, and direct retainer on the distal extension. I'm gonna consider stress releasing clasp on tooth number 4 and 12, and indirect retainer on the canine. So will be the design. U shape, guiding plane, direct retainer. Again, we use the stress releasing clasp, RPA on both sides, and indirect retainer on the anterior teeth. So we reviewed the preparation for the partial denture abutments and the cast design.